And we're on the internet.
Yay!
Yay.
Be careful. You can hear yourself, so you got to keep it quiet. All right.
Close, Mr. Murphy.
And so it begins. So in this problem here, you've got a whole bunch of junk that's not happy where it is. Right? Send it to where it's happy. Okay? Now, in the denominator, in the parentheses, can I combine those two? Do they have the same nth root? Yeah, they do. Since they have the exact same nth root, that means I'm going to have 1 over the 4th root of x to the 8th quantity squared. Combine the x cubed and x to the 5th. Okay. Now, what's the 4th root of 8? Or how about this? How many times does 4 go into 8? Twice. What's your final answer? Auto pair. 1 over x to the 4th. You're done. Yes, ma'am.
What's that name had?
Nope, 4th root went away when you divide out. Remember, the 4th root of 8, 4 goes into 8 how many times? Twice. So it's gone. There's nothing left. There's no leftover. Okay? What else, guys? What's the next one? 66?
74.
All right, 66. Once again, take care of your numerator first. In the numerator, do they have the same nth root?
Yes.
Yes. So that means I can rewrite it as 2 square root of x to the 4th over, what's the square root of 9? What's the n value outside of the root that you don't see? 2. Remember, 2 for square root is always 2, right? So 2 goes into 10 how many times? Any leftovers? What's the square root of x to the 4th then? X squared. Now you have 2x squared over 3x to the 5th. And you should be able to tell right now how to simplify the last bit. I hope. These go, this becomes, so your answer is 2 over 3x to the 5th. Yes, ma'am. What I'm doing here is I'm taking the square root of 9 and the square root of x to the 10th. Remember, the root out here is a 2 that you don't see. So the square root of 9 is 3. And then 2 goes into 10 how many times? 5 times, and there's no leftover. So it's gone. So the root's gone. 2 goes into 10 5 times. Oh, okay. What else, guys?
74.
Same idea. What I'm going to do here is split up the numerator and denominator, take care of them separately. Square root of 9 x squared y over the square root of 32 c to the 3rd. What's the square root of 9? What's the square root of x squared? So this becomes 3x root y in the numerator. In the denominator, what's the square root of 32? What was it? Perfect. It's 4 root 2, and then what's the square root of z cubed? 2 goes into 3 how many times? 1, so you take 1 out, and you have 1 left over. Okay? And then lastly, do you like to have radicals in the denominator? No. So this being just a square root problem, it's a little bit easier to deal with because we've worked with rationalizing denominators in the past. We multiply the top and bottom by the root of 2z. So square root of 2z times the square root of 2z is 2z. So you have 3x root 2yz over 8z squared. What's that? Remember, close only counts in horseshoes and hand grenades. I'm older.
I didn't
No. And I think the last one was, what, 72? I think 72 might be the trickiest of them all as of right now because you have to create the perfect cube root in order to simplify your denominator. So if you're looking at it, you've got the cube root of x. X has an exponent of 1. What is the next multiple of 3 that comes after 1? 3. So what would you have to multiply the x by to turn into x cubed? X squared. So multiply the top and the bottom by the third root of x squared because what you're doing is you're creating a perfect cube root in the denominator. By creating a perfect cube root, you get, what's the cube root of junk cubed? Junk. So the cube root of x cubed is x. Oops. Oh, these goes. All right. Seriously, do that. I don't need to say your name online, and your mom or dad might get mad. She's staring at the computer now, like, oh crap. Yes, sir. Oh, I forgot the 4. Yeah, yeah, there's a 4 there. Sorry. Sorry about that. Okay. Make sure your name's on them.
Wait, that's it? That's it?